This video we will talk about at a very high level JVM and how that JVM architecture relates with the static keyword in Java. Um, but it does apply to any other programming language in a sense that they won't have any JVM. Um, but but the concept lies there, right? So there's something at lower level that kind of resonates to JVM. But anyway, so um, I have gathered animation that will help you show uh, the importance of a static keyword in relation to JVM, all the way from the Java side of stacks to memory level heaps, and then also the class loader, and also one of the most important thing would be metadata that JVM keeps to being tracked with garbage collection. All right, so without any further delay, let me start with the animation, and I'll go through that. But if you have any question, feel free to comment or feel free to DM me, and we can connect. All right, as you can see, um, it's a memory architecture, but this won't be like an architecture diagram. But couple things to note here would be, or things to remember would be, class loader subsystem, metaspace, heap where objects are stored, and stacks where the method and local variables will be stored, right? Anyway, so we'll cover this, but let me start with the flow actually. Uh, the phase one would be class loading and static initialization, but before that as well, phase the zero, let's say, would be I somebody would write a Java program and then they run it, right? Is when the phase one starts class loading and static. But for example, for this example, I created a example class and I initiated the static variable uh, and then the static block. I also created the instance variable and a method called static method. Remember, this is a static block here, and this is a static method here, which does not return anything. It's a void. All right, so now the entry point of any Java program would be static void main, right? So here what I have done is I've instantiated the example class, and the reference name is object1. I also created one more object, a second object of that particular uh, example class, and I'm also calling static method, uh, right? Now these will help us cover many scenarios involving static keyword. So first thing what happens is, so parallelly, two things will happen at the same time, pretty much at the same time. What the class loader subsystem inside the a Java architecture does is convert that example.java class, right, that we had here, example.java. This will be, and then the text inside this will be loaded by class loader, okay? And it converts that to class to rename that extension for it to read. It cannot read .java. So what it does is next it makes sure that the request that it has is a actual valid bytecode. And if that's good, then it starts the preparation of memory allocation and all, which we'll cover later. Now, and then the second part would be the meta space. It needs to understand the meta space of any object, right? So it, at a very high level, it will try to learn like what does this particular class has. So it will meta load all these saying, hey, I have these static variables, I have these method names and all. So as you can see here, and I'll explain further, but this meta space is very important, which is hardly talked. This space corresponds with the garbage collection. So it's a friend of garbage collection, and it also directs the garbage collection in the right direction. All right, so these things happen, and let's click next phase. Now the next phase also would be um, stacking of the objects into the heap, and then stacking like method, and then the local variables into the stacks of JVM. And obviously on the memory side of things, objects are stored in heap. And then the as I told earlier, right, object headers, the garbage collection part of things also is in sync with the metadata. That's how garbage collection knows that any particular object is started based on the meta space, and then the the JVM, it talks with pretty much everything both ways, and it knows when to clear any object, or uh, if it's not in use, just remove it, kind of thing. And then that is where the class points to any particular method area, which the method area would be JVM stacks at a very high level. But if you want to really go deep into this, there are pretty good documentation from Oracle itself. Okay, and same process happens repeatedly. I created multiple objects, two objects here to show you the process. It repeats itself. Let's say if I have 100 objects, it will go and create 100, but the process remains the same. Let's see what happens next. Now the main method will be stacked, and then the any local variables will be stacked here. Then the static method will be stacked. And then remember the stack, right? Stack is LIFO, so it will be a last in, first out. And then method execution context, we can relate something closer to like a string context, but the context of that particular request, particular flow. And then it's the same repetition, same cycle over and over actually until um, it reaches the end of the cycle itself, right? Let's say the program shuts down correctly, then what happens? Object creation doesn't happen anymore, and that object is not used. And garbage collection happens. When garbage collection happens, all of these, like this one, that are in the object, these objects on the heap, right, will be cleared. More memory provided, right? So um, and thinking if I'm missing anything here. But yeah, this is pretty much at a very high level uh, on the importance of the static keyword and how Java loads everything. But and also for any interviews, I would always make sure that I remember these four things. Class loader, meta space, heap, and stack. All right. Hopefully this video was helpful, and thank you for being here all the way to the end and listening to what I have to say. Thank you.